Hi, this is Mr. Chu and you're welcome to my channel where we solve mathematics topics in very easy ways. I encourage you to subscribe to this channel if this is your first time of viewing this, and share with your friends for more videos. Let's come to the lesson for today, expressing numbers in standard form. Standard form is used to write very huge or very small numbers, and very small numbers are numbers that are 0.000, a number of zeros before significant figures. They are numbers that are written in standard form, and very soon we are going to check how you can write a very big number in standard form and then a very small number in standard form. So how do we do that? We say that writing number in standard form is writing a number in the form a times 10 exponent n, where 1 is less or equal to a less or equal to 9 and n is an integer. Let me just explain that quickly. Meaning that we are writing a number in the form a number times 10 exponent something, where that number there should be from 1 to 9. That is what this means, from 1 to 9. And then the exponent should be an integer, meaning that it will be a whole number when you are writing a number in standard form. In writing numbers in standard form, it's just basically we moving the point, the decimal point, to come between the first and the second significant figures. That is just what we are doing. Because when I say the first and the second significant figure, it means that the number that the first two numbers that are not zeros, your decimal point should come between them. And that is why this is here. Meaning that we cannot have two numbers before the decimal point, because with that it will be more than 9. And we cannot have 0 2. So that is what it means. Let us take an example now, and I will use that to explain. Yes, the examples have a general instruction, which is write each of the following numbers in standard form. And the first number is 468,562. For every whole number, the decimal point is an imaginary point that is after the last digit. That is it. So our aim is to move the decimal point from here, which is the last digit, to come between the 4 and the 6, which are the first and the second significant figures respectively. Those. And this is the rule that applies to the movement of the point. When you move the point to the left to give you what you want, you get a positive exponent. And then when you move the point to the right, which is in the case of decimal number 0.000 something, when you have to move the point to the right for it to come between the first and the second significant figure, it gives you negative exponent. So here we are just going to move the point from the far end, and let me repeat that. For every whole number, the decimal point is after the last digit. So here our point is here. We move it from here 1 2 3 4 5. It moves 5 times to come between our first and second significant figures. So our number now becomes 4.68562 times 10 exponent 5, because we moved the point 5 times towards the left, and I said a movement towards the left gives a positive exponent, and a movement towards the right gives a negative exponent. So when we move the point from here, it has come between the 4 and the 6. That's why we have 4.6 here. And then we move it 1 2 3 4 5 times together. That's why we have the exponent 5 there. And the exponent 5 is positive because we move the point to the left. And this is another meaning for this question. It tells us that as we have this number in standard form now, if we want to get the original question back, we have to move it to the right, positive. You have to move it to the right 5 times for us to get our original number back. So whatever exponent of 10 you have, that is telling you where you need to move the point to get your answer back. Let us take example 2. 1282.32 in standard form. Here we can see the point. So again, our main aim is to just move it to come between the first and the second significant figures. So that is what we are going to do. We are going to move it 1, 2, 3 times to come there, and that will give us 1.28232. Remember, the point is no more at the first place, so we are not going to bring it. Times 10 times. We have moved it 3 times, so 3, and towards the left, so we have positive 3, telling us that if we want to get this number back, the way it stands now, we should move the point to the right 1, 2, 3 times, and we get our question back. That is what it gives us. Let's go straight to question 3, which is 0.057. This is the first question on the second explanation I gave about the movement of the point. Here we are moving the point towards the right. So what does that mean? Good. It means that we are now going to have a negative exponent because we are moving the point to the right. So here, how many times do we have to move? This is the first significant figure, and this is the second significant figure. So our aim is to move the point from here to come between the first and the second. And when we do that, we are going to have 5.7 times 10 first. Then how many times did we move the point? 1, 2. So 10 exponent negative 2. Then our answer again tells us that if we want to get this number back, the negative means that we should move the point to the left 2 times, and it's going to give us this number back. We take the very last one on this, which is number 4. We have 0.000867. The same aim. We are moving the point to come between the first and the second significant figures, which are 8 and 6 respectively. So that is going to give us 8.67 times 10. Then how many times did we move the point? 1, 2, 3, 4 times. We have moved the point 4 times, so it will give us 10 exponent negative 4. So this is all writing numbers in standard form is about, but it doesn't end there. Let us take operations on numbers in standard form, which is a bit more challenging than this, but we are going to apply this. Operation of numbers in standard form simply means the use of the basic operation signs, which are addition, subtraction, multiplication or division, to work out numbers. That is just what operation of numbers means. Good. We are taking the very first one with the general instruction as without using tables or calculators, evaluate each of the following, yielding your answers in standard form. Alright, and the very first one we have addition. So we have a number written in standard form plus another number in standard form. So this is general rule about addition of numbers in standard form. When the exponent of the exponent of the 10 in the 2 terms are the same like this case. This is 10 exponent 3, this is also 10 exponent 3. The easiest and the shortest thing for us to do is to add the 2 numbers and then keep one of the exponents. If our answer is not in standard form, we convert the result from the addition to standard form, and then we evaluate our final answer. So we have example here. Let us work that one out. Then we go to example 2. So what I was saying, now we are going to have 5.42 plus, or let me just do it this way, 5.42 plus 5.58, then times 10 exponent 3. We are just choosing one of them because this and these are the same. So the easiest way is to choose only one. Then we do the addition. So here is going to give us 5.42 plus 5.58. 2 plus 8, 10, we put our 0 here, carry 1. This will give us 10, so we put our 0 here. We bring our points. Remember, when you are adding, no matter how the numbers are written, make sure your points are in alignment. So we have 10, put 0, carry 1. And that 1 plus this 5 will give us 6 plus 5, 11. So this is going to give us 11.0, or we leave it. 11.00 is the same as 11. So 11 times 10 exponent 3. But then we can see that this one is not in standard form, because standard form said we shouldn't have 2 digits before the decimal point. Here the decimal point is here. But we shouldn't have 2 digits before the decimal point. That is why it should always be between the first and the second significant figure. So you are going to change this 11 alone to standard form. Using the examples we did earlier, this is going to give us 1.1 times 10 exponent 1 for the 11 alone. Then times 10 exponent 3, which is here. And this is going to give us 1.1 times 10 exponent 1 plus 3, according to the laws of indices. So that's going to give us 1.1 times 10 exponent 4. And this is our final answer for this in standard form. This is one way of working, and the easiest way of working it if the exponent of the two terms of the 10 in the two terms are the same. This is the easiest way of working it. But then we can use a general way of working it, which we will use to solve the second example. And you can try that with this one. After the second example, looking at it, you can try that with this one. And when you finish, you convert your answer to standard form. You see that it will still give you this one. So let's take example 2 quickly. Example 2 with the same instruction. But like I was saying earlier, this one has 6.3 times 10 exponent 8. And this has 2.2 times 10 exponent 9. They don't have the same exponent of 10. This is 8, this is 9. So we cannot repeat one of them, because we will not know whether we should repeat the 8 or we should repeat the 9. And as a result, we will need to change each of them to the ordinary form, from standard form to the ordinary form, and add them. After adding them, we convert our final answer to standard form. So that is what we are going to do. Looking at the first term, this is 6.3 times 10 exponent 8. The exponent 8 positive means that for us to get what this, the original number back in the ordinary form, not be in standard form, we need to move this point from here to the right 8 times. That is what this number in standard form gives us. So that will be 6.3. We are moving the point to the right 8 times. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8. Then we fill in all of these with zeros. So we are going to have 1, 2, 3, 4, 5, 6, 7 zeros. Now this is equal to 6, 3, then 1, 2, 3, 4, 5, 6, 7 zeros. Plus, we do same to this. We are going to move the point to the right because it's positive exponent. We are going to move the point to the right 9 times. And now give us 6, 2 plus 8 zeros. So it will give us 2.2. Then we move 1, 2, 3, 4, 5, 6, 7, 8, 9. And that will give us 1, 2, 3, 4, 5, 6, 7, 8. So 8 zeros for this one. After getting this, I said something when we were solving example 1 that our points have to be in alignment. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. before the decimal point, and all the digits before the decimal point must come so that the decimal point will be at the same place. So because this is 10, it means that one of the numbers must shift to the right. So we are going to have our 2 here. So 2, 2, then 1, 2, 3, 4, 5, 6, 7, 8. This is how it's going to be, because the decimal point must be in alignment. If you don't work it well and you don't make the decimal point to be in alignment, so that if possible you can fill the other spaces with 0 so that they get the same thing, then you add. So this is what we are going to get. We now do our addition. All this will give us 0, 0, 0, 0, 0, 0, 0. 3 plus 0 is 3. 6 plus 2 is 8. 0 plus 2 is 2. So this is our final answer, but they say we should leave our answer in standard form. That means the point that is originally here, we are moving it all the way to come between the 2 and the 8, so that we can get our number in standard form. So that will give us 2.83. Then times 10. We'll see how many times we are going to move. So we are going to move the point from here 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 exponent 9. Remember, we move the point to the left. So our exponent is supposed to be positive. And remember, changing to the ordinary form the way we did it. And more importantly, for addition, the fact that the decimal point must be in alignment. So it doesn't matter which numbers come, you have to write them in a way that the point will be in alignment so that you can do your addition. This is what we get. Let's just go to the example 3. Good. Example 3 has moved us from addition to multiplication. Remember, it's operation, so we are putting all the operation together. Then subtraction, I didn't bring anything on subtraction because it's the same as addition, only that the answers we will get will be subtracting. Then we change our final answer to standard form. So let's do multiplication. We are going to do same here. We change each of them to standard form. This will give us 1, 2. So this will give us 6 times 10 exponent negative 2. Remember, we move the point to the right. Then times 9 times 10 exponent negative 3. Same here. Then now we are going to multiply the whole numbers together. Then we multiply the indices together. Let's just do that now. That means we are going to get 6 times 9, then times 10 exponent negative 2 times 10 exponent negative 3. 6 times 9 is 54. So 54 times this one by our indices is going to be, we are adding, but this is negative. So it's going to give us negative 2 minus 3. And that will give us, we will simplify all alongside. This number here, remember, is 54, but it's not in standard form. Because this is a whole number, meaning the decimal point is here. But the decimal point is supposed to be between the 5 and the 4, which are first and second significant figures respectively. So that is, we are going to change that to standard form while we work this one to alongside. This one alone will give us 5.4 times 10 exponents 1, because we have moved the point to the left. Then times 10 exponents negative 2 minus 5 minus 3 is negative 5, which is the answer for that. Then that will give us 5.4 times, we are doing indices for this again. So 10 exponents 1 times 10 exponents negative 5 means 1 plus negative 5, which will give us 10 exponent negative 4. And that is our final answer for this, for multiplication. Again, we change each of them to standard form. Then after that, we multiply the whole number part, or the part that is not in the indices form together Then we put the indices two together. When we finish, we put our answer. Let's go to the next example, which is example 4. Example 4 is the same instruction, but in terms of operation, division this time. And like I said, we are just going to do the same thing. So here we are going to have 9 times 10 exponent 1, 2, 3, 4. So 10 exponent negative 4. Then the whole of this divided by 12 times 10 exponent negative 3. Remember, this is not necessarily in standard form, but we turn it into whole number so that we can do the division. So that's why we move it 1, 2, 3 instead of just moving it twice. We want the 12 to be whole number so that we can do the division of whole number, which is easier. Then we convert our answer again. That is what we did. So this will be the same as 9 times 10 exponent negative 4 divided by 12 times 10 exponent negative 3. And when we do this, 3 will go here 3 times, goes here 4 times. 3 divided by 4 give us 0.75. Then times 10 exponent negative 4 minus negative 3 according to the laws of indices. So this is going to be, this is not in standard form, remember. So this is going to be 7.5 times 10 exponent negative 1 to put this in standard form. Then times 10 exponent negative 4 plus 3, which will give us negative 1. So this will give us 7.5 times 10 exponent negative 1 plus negative 1 will give us negative 2 according to the laws of indices. And that is our answer. We'll take a few more examples that will put all these things we have learned so far and other things we did in indices into challenge or into practice. It will challenge us to remember those things. So let's take a bit more challenging examples before we bring today's study to an end. With the same instruction, example 5, combine example 3 and example 4 together. I mean that we have multiplication here, and then we have addition of the numerator and the denominator. And we are just applying the idea we used in example 4 above to solve. So we are going to change each of these to whole numbers so that we can easily work with them. Then after that, we take it from there. That means this is going to give us 36 times 10 exponent negative 4, because you have to do 1, 2, 3, 4, or 1, 2, 3, 4 to get our 36. Then times 343 times 10 exponent. We are moving the point 1, 2, 3, 4, 5, 6 times to the right, so negative 6 all over 49, because we are looking for whole number, times 10 exponent negative 5 times 6 times 10 exponent negative 3. Alright, so the basic thing here is that this one is multiplying this, and this one is also multiplying this. When we finish, we divide. But you know one thing about fractions or multiplication of fraction is that you cancel out if there is a common factor between the numerator and the denominator. So you are going to check that so that we can have smaller numbers to work with. But it doesn't matter if you use your calculator to multiply this and this. You write your answer down, you multiply this and this, you write your answer down, and you divide. But I am going to divide because I am not using calculator right now, which is no problem. You can choose to use calculator. Then I have smaller numbers to work with. So I know that 6 will go into itself here 1, and go into 36 here 6 times. 49 go into itself here 1, goes here 7 times. So we are now going to have our whole number part to be 6 times 7, which is 42, times 10 times negative 4, inferring from the way we solve example 4, then minus 6, because they have the same base and they are multiplying. All over, here 1 times 1 is 1, times 10 exponent negative 5 minus 3, because they are multiplying, but one of them, the second term is negative, so negative 5 minus 3. So we jump in some of the steps quickly. 42 over 1 is the same as 42. So that will give us 10 exponent negative 10, negative 4 minus 6, negative 10. Then divided by 10 exponent negative 8. Or if we can jump that because of how far we've gone with lots of indices and then this topic, we'll say that minus, because of the division, the negative 5 minus 3 is negative 8. So we put the negative 8 in brackets. So this one, the negative 10 for this one, then minus, because this is dividing the top one, because that's why we have the minus here. Then the exponent is negative 8, so we brought that. We work it further to give us 42 is not in standard form. So in standard form will be 4.2 times 10 exponent 1 for the 42, then times 10 exponent negative 10 minus negative 8 will be negative 10 plus 8, which will give us negative 2. So exponent negative 2, 10 exponent negative 2, and that will give us 4.2 times 10 exponent 1 minus 2 is plus, but the second term is negative. So 1 minus 2 is negative 1, and that becomes our final answer. So this is how we can work these type of fractions where the numbers are in decimals and we are asked to work them out and leave our answers in standard form. Remember the key terms here that we are not using tables or calculators. And not using tables or calculators doesn't necessarily mean that when you get it, you shouldn't multiply this and divide. But it only means that you should show step by step working how you got your answer. That is just how or what not using tables or calculators mean. It means you should show working. And this one happened for essay questions, or what some people will call the section B questions, where you need to show working. Let's take the next example. Looking at question 6, which will probably be the last question for today's study, we can see that the difficulty level has increased, because here we have something that looks like example 5, but it is now in a square root. And I think this can be one of the most challenging questions students can find. So we are going to attempt solving it and see what we get at the end of the day. Good. So we are going to work everything in the square root first, and then when we finish, we tackle the square roots. Let's go. So this will give us square root of the top one will be 72 times 10 exponent negative 4 times 28 times 10 exponent negative 2, then times 10 exponent negative 13, which is already here, all over 14 times 10 exponent negative 3 times 9 times 10 exponent negative 2, then times 10 exponent 8. Alright. Now we check again, just to reduce the numbers we are working with. We check whether we can get common factors between. 14 will go into this here 1, goes here twice. Then 9 will go here 1, go here 8 times. Let me just put it inside here so that it will show that it's in the root. Then That will give us 8 times 2 is 16 times 10 exponent negative 4 times 10 will give us minus 2 times 10 exponent this will give us minus 13 all over 1 times 1 is 1 times 10 exponent negative 3 times negative 2 will be minus, or times 10 exponent negative 2 will be negative 2 times 10 exponent 8 will be plus 8. Don't forget to bring your root, it's still in the square root. Then this will give us 16 times 10 exponent negative 4 minus 2 negative 6. Then negative 6 minus 13 is negative 19. So negative 19. Then this one, because it's dividing, I want to bring my minus. Then here negative 3 minus 2 negative 5 plus 8 will give us positive 3. Then because it's dividing, you are subtracting, so minus 3. Don't forget our square root. Then this will give us square root of 16 times 10 exponent negative 19 minus 3 will give us negative 22. So remember, by set, this will be the same as square root of 16 times square root of 10 exponent negative 22. Alright, so this will be the same as square root of 16 is 4 times 10 exponent negative 22 times 1 over 2. Remember, laws of indices. Square root of a number is the same as exponent 1/2. So this is standing for the square root, and this already is. So this goes here once, goes here negative 11 times. So our final answer will be 4 times 10 exponent negative 11 as our final answers. And dear friends, this is where I want us to end these studies on standard form. I hope it's been helpful. If yes, why not subscribe to my channel for more videos anytime I upload them, so that you get the notification directly, and also encourage your friends to subscribe and then like, comment. I want more comments on the things we do every day. I want more comments on my videos. The help you think is offering you, just give some comments. So until we meet in my next video, thank you for watching. Bye bye.